Hello, this is Ogama, mathematics teacher. Welcome to Mathematics Gymnasium. Today we are going to discuss quadratic equations. A quadratic equation is a polynomial of the form. Polynomial equation, mind you. Ax squared plus bx plus c equals 0. Where a, b, and c are constants, as in 2x squared minus 5x plus 3 equals 0. So if we compare the coefficients, it means that a in this case is 2, b is negative 5, and c is equal to 3. So this is the general form of a quadratic equation. This is an equation as against what we had in the previous class, which was limited to expression. That was because of the absence of this equality sign and this 0. Funny enough, ordinarily, we would have considered that this is as good as what we had before. But the presence of this sign makes the difference. The presence of this sign suggests that this could move from here to here, and we can have something more robust than what we have. But the absence of this portion limits it to an expression. So the best that could be done would be to factorize. However, that factorization has become an instrument with which we can solve this. Now, if all of this is equal to 0, what could x possibly be so that when it's substituted into this expression, it adds up to 0? That is the solution of this. And usually, there are always 2 for any given quadratic equation, which may be distinct, as we are going to have here. And when I say distinct, it means that x is equal to, say, a, or x is equal to b. There are 2 values that will satisfy this. I'll solve this using factorization method. 2x squared, it implies, going by our previous knowledge of factorization, we can have this to be negative 2x, it's also going to be negative 3x, then positive 3 being equal to 0. Now, we are just carrying this along. We don't have anything to do with that yet. So we identify the highest common factor between the first 2 terms, which is 2x into x minus 1, negative 3 into x minus 1 equals 0. So we now have 2x negative 3 into x minus 1 equals 0. Now, from our elementary school, we have been told that whenever 2 items multiply each other and the product is 0, the implication is that one of the items must be 0. So what that suggests is that it's either 2x minus 3 is equal to 0 or x minus 1 is equal to 0. So if that is the case, then 2x is equal to 3, or x is equal to, when this crosses here, it becomes 1. Now, if 2x is equal to 3, then x will be equal to 3 over 2. Like I said, that there are usually 2 values for x. Therefore, for this equation, x is equal to 1 or 1.5. These are the 2 values of x, which when substituted into this, the whole equation will add up to 0. Now let's check. 1 times 5 times negative 5 is negative 5. 1 square is 1. Times 2 is 2. 2 plus 3 is 5. 5 minus 5 is 0. That satisfies the equation. 1.5 times this is going to be 7.5. 1.5 square is 2.25. 2.25 times 2 is 4.5. 4.5 plus 3 is 7.5. 7.5 minus 7.5 is 0. Those are the two values that can make this equation consistent. And those are the ones we have found. If you observe, you find out that we did not do anything different from what we did except in the previous lesson, except at this stage when we realize that, okay, the product of this, having factorized it, equals 0. So it means that one of these, because everything in this pair of bracket is considered to be a single item, and everything in here is considered to be a single item. So if this is, the product is 0, then it's either this is 0 or this is 0. And if this is 0, it means that 2x is negative 3. And it's 3. And that's how we arrived at that. So there are 4 methods of, I said that they can be solved using any of 3 methods. The fourth one, you don't negotiate it because the machinery will already be set in motion and you just have to tag along. So you cannot decide to solve it using factorization if you have been told to copy and complete a given table, and from the table that you have completed, you should go ahead to plot a graph, and after which you'll be told to find the solution of the graph. You cannot do otherwise. So that's why I said it can be solved using any of 3 methods. The fourth method is not negotiable. You just have to tag along. So graphically is another method of solution of quadratic equation. So having talked about different methods of solution for any given quadratic equation, it is important to state at this point that it is not every quadratic equation that would be factorizable. So if the quadratic equation is not factorizable, then it requires another method of solution. Then any of these other methods could be deployed, but certainly not graphical method, because you cannot just start applying graphical method. So we have discussed, or I have solved an example with the factorization, and going by what we have done in the previous class, so factorization is more or less like a walkover. I have only demonstrated how it could be, transferred to solving quadratic equation. The other method I'm going to apply in this class is formula method. Formula method. For any equation, and when I say equation at this point, I'm talking about quadratic equation of the form ax squared plus bx plus c equals 0. X is equal to negative b, positive or negative the square root of b squared, negative 4ac, everything over 2a. And this is the quadratic formula. That is where a, b, and c are constants. So I can pick any of the expressions that I had factorized in earlier, or just any quadratic equation. Now the good thing about this formula, as well as completing the square method, is that even if the quadratic equation is not going to have a real solution, in other words, if it is going to turn out to have a complex solution, the formula will stick. At the end of the day, it will not make sense. Okay? This is factorizable. So what are we going to have? We will now have, it implies that a is equal to 5, b is equal to negative 3, not 3, and c is equal to negative 2. So it implies x is equal to negative bracket negative 3 positive or negative the square root of negative 3 squared, negative 4 into 5 into negative 2, everything all over 2 into 5. So when I simplify this, I'm going to have x equals, this becomes 3 plus or minus, if I square this I'm going to have 9, positive 9. Because this is negative and this is negative, this is going to give me 40 altogether. This times this is negative 20 times negative 2 will give me positive 40. So I will now have it to be root 9 plus 40, everything all over 10. And that will be 3 positive or negative root 49 everything over 10. Now 49 is a perfect square, so it means I'm going to have x will be equal to 3 plus 7 all over 10, or x is equal to 3 minus 7 all over 10. So x will be equal to, okay, let me just get done with it. This is 10 over 10. X is equal to 1 or negative. If I subtract this from this, I will have negative 4 over 10, which is going to be negative 2 over 5. These are the solutions of this equation using the quadratic formula. You may want to check the consistency of the methods and attempt factorization method. You will still get the same thing. So this is simple, but it's important that if you want to apply this formula, you must state the formula like I did here. Okay, what I did here is because I still have it here and because of space. If not, ordinarily, if I am solving it ordinarily, I would have stated, given this, then it is of the form, I will state it that it's of the form ax squared plus bx plus c equals 0, where a, b, and c are constants, such that x is equal to negative b positive or negative the square root of b squared negative 4ac everything over 2a. I will now infer, therefore, that a is equal to this, b is equal to this, and c is equal to this. So it would then imply that x will be equal to them. I put them in and solve the way I have done. So take note of that. If you have any question, why not? Feel free to put them in the comment section. Of course, you can always make use of the